I'm good.
Hello, I'm Jack Rickard with EVTV. This is my compadre and consigliere, El Brandotto.
Hey, what's up, Jack?
It's a very dark Friday.
It is almost black.
They call it Black Friday. What is all this about?
I don't know.
When I was a kid, they didn't have a big shopping day after Thanksgiving. I think this is all made up by the retailers.
I think so, especially one that starts at midnight or 4 o'clock in the morning.
And they call it Black Friday. What's that about?
I don't know. It's a shopping day, but I don't know why Black Friday.
They've been talking about it all day.
I know. It's Black
Get
Friday.
out there and spend some money, and apparently people are. Meanwhile, we're in the day after Turkey Day, back in the shop, kind of slaving away here.
I know. Huh? Look what we do for you guys. While you're out there shopping, we're here, away from our wives. Did I just say that? Did I just say that?
Oh, well. We got some stuff going. What do you got going with the...
with a swallow.
Swaller.
Well, we've been working on it. As you can see, we got it stripped down to the pan. We've been cleaning it up, painting it a little bit.
If you paint it black, it'll disappear.
Paint it black, it'll disappear. We did find...
A little Rust-Oleum.
Yep, we did find a bad master cylinder.
We showed him that.
Showed him that. Yep, a new master cylinder, that's right.
So you got a new master cylinder and a clevis pin on here?
Yeah, we got
This is a clutch hydraulics.
Yeah, this is a CNC is what we replaced it with. Just an all aluminum here. Little. We're gonna replumb it here because the cable or the hose, excuse me, came out a little different on this one. Also, I'm going to do it so it doesn't come through the body this time. We had to lift off half of the
to disconnect all that to
because it came off. It went through the body. So I'm going to run it up under here so we can just pull the body off this time.
Excellent. And our master cylinder for the brakes are good.
Master cylinder for the brakes seemed to be holding pressure when we took it apart, and I've drained it in the meantime, sucked all the fluid out of it, and we're going to fill it back up again with new fluid and wheel cylinders and brake drums, everything.
Our Cobra projects had a bad effect. Now everybody wants a Brazilian horsepower.
Uh-oh.
And they don't even know what a horsepower is. In
they just like it.
Context of an electric vehicle. I had a guy with a notchback Volkswagen.
That's a pretty cool car.
Asked me what to use. Yeah, it is kind of a.
It is kind of a cool.
Hard
little,
to find.
No, it's like a little sedan looking car.
He's got a gorgeous little black one.
Really? Oh, those are really cool.
So he writes and asks me which drivetrain to use.
Okay.
What would you use?
In that notchback?
Yeah, 2,100 pounds.
I mean, it would be a good candidate for the HP EVS system.
Yeah, that's what I told him.
For an AC system.
Let's get a little AC 50, like Speedster does. Oh, no. After he writes and asks me, then he's like, oh, no, that's not enough power.
That's not enough more power.
He wants a 9 or 11 inch with a solid tine and all this. I said, well, you go, girlfriend, but there is an appropriate thing for every car, and no two people are going to do it the same, but if you ask my opinion in that weight class, and so that's what we're going to use on this.
He wants a race car.
This is going to be like we're going to make a race car here. This is going to be like a 1,500 pound with an AC 50.
Yeah.
This one's going to be a little twitchy.
Yeah.
But I had ordered, just because I wanted to have them around.
Yeah, just in case they don't make them anymore or something. God knows what happens.
Low Car makes this little oval, black and billet.
Yeah, that is pretty cool.
Accelerator in their drive-by-wire series.
I like
Recall
it.
we used that in the Cobra.
The Cobra, yeah.
Now, the spring action is still a little bit light.
Yeah, these have been recalled to make them heavier.
Right. These were increased, but it's still a little light to me. But isn't that a cute little pedal for a Volkswagen? I
like it. So yeah, that'll work good.
We'll use that with the AC 50. And I did finally find you a brake transducer. Where's that?
It's right behind you, Jay.
Right behind me.
There you go.
This is a, I've lost my glasses now. Read it to me, the part number. MEAS. What is that?
It is an MEAS. The part number is a 2000202. And this model is MSP 300-250-P-3-N-1.
These part numbers are kind of curious. You can break this down. I get these on DigiKey.
DigiKey, yeah.
And the part number breaks down everything. Part of it is the size of this screw-in sensor.
Yeah, and that must be what, a quarter NPT or something?
Quarter NPT or something.
Then
NPT, the 250 is this puts out 0 to 5 volts at 0 to 250 psi.
Okay, okay.
And we're going to have every bit of that, but that'll be a fairly sensitive. We've used the 0 to 250 and the 0 to 500.
500, yeah.
And this will be a 0 to 250, fairly sensitive brake pressure transducer. Braden's going to somehow put a block
put a T in there, yeah.
Brake lines up forward and sync this into it. Then we'll take zero ground and 5 volts from the Curtis 1238-7601 controller, and there is an input for regenerative braking on that will be the white wire, I'm pretty sure, on this, and that's something between 0 and 5 volts. And then we can calibrate that in with the amount of regenerative braking we want. And so when you take your foot off the accelerator, you will get regen, but when you put on the brakes, you'll get more regen.
And it works really good on both our the Spider and the Speedster does.
Yes, it
really works.
We were actually building them out there, kind of tried to talk us out of that, that they had played with it and that they hadn't had good results.
It works pretty good.
We've been having great results.
Yeah, it works really good.
I think in some of the heavier cars with higher brake line pressures, they were smoking the transducer. But on these light ones, we're just not having that problem.
We're not having an issue, yeah.
And it gives you a very good touch control of the braking. And so that's what we're going to do there. What else you got going on?
Well, we also put on in the rear there a, that's the slave cylinder for the clutch, and we took the old one off because while you're at it, you never know. It's a $30 part, and sometimes when they're installed the way they used to install them, which is to use the stock Bowden tube, we showed this last week, where the clutch used to come through and then the cable would come out the rest of the way. This wiggles around in there and it side loads and it tends to oval out this fitting. So we don't even know if it was good, or if it was, it might have gone bad. So we put a new one on, and we put on that block. If you can see the billet block.
A new bracket here.
And yes, and what
it isolates all this very nicely.
Puts it at a good angle, and that's with a Heim joint, and that's the way it's supposed to be mounted. So
there's your line. So
if any of you do that with a VW or any Masters, any slave cylinder setup, always make sure that that thing is in there really tight and at almost parallel. And it won't side load, and it'll just work better and last longer.
So we'll have a hydraulic clutch. That'll be great. What about our rotors and drums?
Well, we sent them out. Our stock ones were in pretty good shape, and we just sent out our rotors in the front and our drums in the rear. Just sent them out and got them resurfaced.
Just got surfacing?
Yeah, just got them resurfaced because they're plenty thick.
Up a little bit.
Yep, and they're so that should be good. We're going to use the the stock calipers again, all stock brakes, the drum brake in the rear. It's ready to go. We're just waiting for the pads and the wheel cylinders and things from CB Performance.
Oh, that's right. We're going to put a new wheel cylinder on here.
Yeah, new wheel cylinders, brake
bearings.
pads. Yeah, we've got bearings in the front. There was no leaks in the rear, so I didn't touch the rears.
Right.
But the fronts we're going to put, because the this car just been sitting around a while, and who knows how many miles the pan had on them. That grease had pretty much, the wheel bearing grease pretty much turned almost like just 90 weight oil. It was not very thick. So chances are, and it smelled bad, chances are those bearings were, again, if not bad, maybe a few thousand miles they would be. So,
Brian, you keep saying that. I keep thinking maybe that guy's using 90 weight oil instead of grease to cut down the roll.
Cut down the roll. It was grease, and it was horribly burned.
Was it?
Yeah,
okay.
It smelled bad.
We, in editing or something, this didn't come across very well last week. Back here, what do you call this?
That's your shock tower. Your upper shock tower, yeah.
And this is your torsion tube.
That's your torsion tube and your cover, yeah.
On the front of the torsion tube is a little tab that comes out and kind of has a little foot under the pan.
Yeah, attached to the pan.
Just a couple inches long here. And this is broken.
It is completely broken apart.
And on the other side, it's cracked. It's nothing up here. It's none of this. It's just the right off the front of the torsion tube exterior.
Yeah, it's that
there's a
outboard
little mount
attachment. Yeah.
to attach to the outboard side of the pan.
Yeah.
And the pan is a 68 Volkswagen pan, but we can kind of do some stuff bracing that up. We'll get that fixed up, but it keeps this from
wanting to go like this down the road.
this way, and we don't want it to do that.
No.
Brian's kind of cleaned this up, put some black Rust-Oleum. It looks pretty good actually now.
Yeah, it's getting better. We're running, we're putting new steel brake. You know, this the instead of the rubber hoses, they were kind of deteriorated. So that's a chance to put steel lines on there. This will be a line that I'm going to run up to the front for the clutch, since in a different location. Yeah, we're replacing those.
So this is like your old rubber brake line,
and it's kind of cracked a little bit. And
so let's put some little.
Yep, we got some steel lines coming. Yeah, but not a lot of upgrading. You know, we don't know yet what the weight's what's gonna do to our shocks. We may need to put coilovers in the rear. If we don't need them, no sense replacing them at this point.
I don't see any leaking shocks. We're actually going to be lighter on this car than we were.
Yeah.
This was 1650.
When he had it done? Okay. When he
had the Optimas.
Okay.
And we're going to be
15.
Below 15, I think.
Yeah, that's pretty good.
And so we're going to save 150 or 200 pounds on this car and have a lot more energy in the battery pack. And so I'm thinking, you know, this will be fine. We need to do something with those headlights. I've ordered some stuff to play with. We also, this week, played the Escalade a little bit.
Yeah, we did.
Let's take a look.
Okay.
We have the Elescalade back from Sling Blade Performance. And
we do.
Jeff, what's his name?
Jeff Lentz.
Lentz.
Jeff Lentz, yes. Out in, I don't know where the heck they are. Dongola, Anna, who knows?
Dongola, Anna, Point South.
Somewhere in southern Illinois.
How'd he do?
You know, he actually did a really good job. Never hesitated to put the Hydro Boost in, and we got it back in, what, 4 days, I guess?
Yeah.
Monday to Thursday. Not bad.
What did he charge us?
It was $700.
That's a lot.
Well, we had $560 of parts.
That's right. So that includes the parts.
That was labor parts. There was a couple $100 in labor.
Good.
Yeah.
So what did we get?
Well, what we ended up getting was we already had purchased the Hydro Boost, which I guess instead of having your old accumulator here and master cylinder, which are, you see in the front of your vehicle, this operates on vacuum. So we're not going to have any vacuum unless
that's the whole purpose.
Yeah, unless we decide to put a vacuum pump or something in, and we just are not big fans of vacuum pumps. They're noisy, they come on and off, and so GM does have a solution that, from what I understand, goes in their diesel vehicles, this Hydro Boost, and it runs off of the pressure created by the power steering pump.
So we needed that Hydro Boost and a new master cylinder and reservoir?
We needed this is a completely different master cylinder. It's quite a bit bigger on the Hydro Boost, and the reservoir is a different configuration.
It looks bigger.
Yeah, everything is larger. Plus, we had to have a power steering pump that had two outlets and an inlet coming off of it. So where our normal one only has two.
And we could have saved a few bucks and just re-hosed the old one. But I wanted it to work with stock hoses.
And that's what we've got. We've got stock hoses.
And so by going to the other pump,
the new
which should fit fine on our front bracket.
It was bolted right up to our stock bracket.
Then we'll be with stock Cadillac Escalade hoses.
Right.
Not Cadillac Escalade, but stock GM.
Stock GM, yeah.
Hydro Boost hoses.
Yeah.
To connect to that power steering pump, to both our brakes and our steering.
Exactly, and we've got, in this particular vehicle, you've got a power-assisted rack and pinion steering, where the application is Hydro Boost it's a regular worm gear. So we managed to use all stock hoses, even down to the into your power rack and pinion.
Cool.
Yeah, so it looks really good installation.
I see a couple sensors there on your vacuum unit.
Well, what we've got on the vacuum unit, and we don't know what's going to happen, these are both vacuum sensors that right now are not plugged in. All we've got.
We still have the harness that plugs into.
Oh yeah, we still got the harness in, and all that we're getting right now in the cabin when I drove back is check brakes. So we are getting a error code, but we may be able to bypass that by retuning it.
Save me those sensors anyway, but
Yeah.
yes, I have a tuner for that E38 ECU, and hopefully we can just make that go away.
Make it go away, exactly.
But don't lose those sensors. And good job. That's quite a relief. That's actually a kind of a big thing gone, out of the way.
Yeah, I mean, I hopped in it, drove it, and I probably was a mile down the road before I realized that we had just rebuilt the brake system. So they felt
And the
exactly like stock.
Like power
everything.
brakes.
Yep, everything. The power steering is working.
Elescalade
Everything felt good.
actually has, you can adjust the pedals.
And you still can.
You still can,
Yeah.
the position. I've never done this, but it's a neat car. The steering wheel is electrically heated. The windshield washer's electrically heated.
Yeah.
It's got a lot of creature comforts.
Yep, there's a lot of stuff, but this was a big one because we wouldn't have known if this all worked until we were done with the conversion. And now we know that we've got brakes.
Yep, I like it.
Yeah, very nice.
What are we going to do next?
Well, I think we can just start taking some things off, looking for room, just maybe a little bit underneath.
We got to put that battery box in. Have you got a plan?
Yeah, what we're going to have to do with that battery box is I think it was about 50 inches, I think, into the bed. The bed is only about 58, 59 inches. So we're going to have to find a couple of places where we can go through the floor of the bed down underneath the truck. So that could be a little interesting. There are some curves and some hollow issues.
Show me.
All right, let's look.
Okay, Brain. We're under the
Yep, we are.
Escalade. I see you've pulled out our exhaust system.
We did. We pulled. There's
Here, almost to the front of the vehicle.
Yeah, there's a one piece all the way from the collectors up there to 2 into 1.
You've got a big green heat shield still there.
We've got a heat shield here. We've got just some little nuts that'll come off. Take that off. Our exhaust system was all the way through here, up over the rear end, back down through here, up around here, and came out over there. So we've also taken out the spare tire. That was the only way to get the exhaust out. So
in the very back, you've removed the spare.
the spare
Good,
here, yeah.
'cause I don't carry a spare with an electric car.
Yeah.
We'll call AAA.
We'll call
or
the tow
something.
truck. Yeah.
And
And basically our bed extends from, back here to about right here.
that's always surprises me. It strikes me as so unusual. This, of course, is like an avalanche truck, I guess.
Yeah.
Similar to that, but it's really a big 4-door vehicle with a little short bed in the back.
Yeah, it really does have a short bed. It's only about, it's like what?
6 feet.
Yeah, it's a 6-foot bed. I think it's 58, 60 inches is it.
5-foot bed. Now.
Yeah, it's really a 5-foot bed.
And to get 8 feet for 2x4s or whatever, you have to lay down the back seat.
You've got the back seats under here, and there's a little crawl through that you take out or knock down as well, and then you can get up into the back seats, up into the front.
And so this is, we think of this as a pickup truck. I think of it as kind of an ideal 4-door electric vehicle.
Yes.
It's going to be heavy, but it has this huge compartment in the back. I think of it as the world's biggest trunk. I've never hauled any gravel in my Elescalade. But it's really a big 4-door vehicle with a little short bed in the back.
Yeah, it is. It is. It's a shorty back there. Yep.
And it has a tonneau cover on it, so it's like a natural battery box.
Yeah.
If we want to give up our landscaping business, which we were never doing,
Which we're never in. Yeah, and
we wind up with a full 4-door sedan vehicle with big seats, big air conditioning, DVD player, the whole thing. But it never really was a pickup truck, was it?
No, not really. You have that option, but I think it's more of a style option than anything.
Yeah, it's on a frame that could be used as a pickup truck, but what really is a big 4-door vehicle with a little shorty pickup bed in back that's barely 5 feet long.
Yeah, that's right.
That would be ideal for batteries and never was going to be any use for landscaping.
No, no.
And so for a vehicle its size, it's going to take a tremendous weight and volume of batteries to move adroitly with this thing and at any range. And that's why we went with the Winston 400 amp hour cells. But it's really kind of unusual as a vehicle because it has a little bed and a big back seat.
A big back seat.
Most pickup trucks have a little club back seat and a bigger bed.
Right.
And so this is actually not as accidental as I've made it look. I've thought for some time this would make the ideal large 4-door, 4 or 5 passenger adult person all-weather electric vehicle, except it's going to be very heavy, and but that's good for the winter. And but you wind up, your bed really only comes up to just in front of those rear wheels, doesn't it?
Yeah, right. Really, yeah, right here. There's a cross brace here, and it's really just right in front of it.
And we need to get to our battery box with 2 quite heavy battery cables. We're using 4 from the box up to the terminals.
Yeah, up front to our blocks, yeah.
And 2 hoses for cooling, or actually heating in this case, fluids.
Yes.
And we have to get through a couple of layers of sheet tin, metal, steel.
Yeah, where I came up through here just to see where I was, because this was the last opportunity to not get into a cavity.
Right.
It starts to curve down at this point, and it's still 2 sheets, but now we've got 2 sheets that are, in some points, maybe 6 inches apart. That we're going to have to negotiate at the top and at the other side and come up with some configuration to put those cables through where they don't have any opportunity to chafe.
What do you got put together for that?
Well, what we were talking about yesterday, Jack, was using the real large gland nut.
Those are huge.
Yeah, that will clamp down on the 4/0, and then using a PVC pipe that we will have to just trim a little bit of the width of the wall.
So it goes inside the.
Yeah, it would basically go, if this was our cavity, it would come. We'll have to probably do it at a little angle like this, since we're going to be up and have to be coming back. And this would go with one of these on top. One of them on the underside. Using PVC glue is what I would suspect that we would be able to use. And then that way we could just shoot the cable through this, basically this chase that we've got, or conduit, and have it come from the battery box below, and then we can begin to run it up to the front of the vehicle to our to a distribution block.
Anyway, you can angle that forward, or it has to be angled back?
You know, I don't know. What I'm going to have to do is just go ahead and drill one of these on the top, see what I can see. You know, the other one that we're going to have to do is going to be over here where our gas tank is. This at least gives me an opportunity to see what we're working with. But yeah, I may be able to come straight down. It's just going to be the my ability to you know, get those holes lined up, you know, one over the other.
Well, just don't leave my battery box hanging a ½ inch too long out the back.
No, we've got, I think the battery box was 50 inches. Was that about 50 or 56, I believe. And we've got, not that much, but we've got maybe 2 inches. And with this, we're going to need
about 2 inches.
About 2 inches, yeah. So we're going to be
pretty close.
All the way up into this area right here is where we're going to be. But we'll put 4 or 5, 2 of them this size, and 3 smaller ones probably through these walls, and get us access with the cables down underneath the vehicle.
So our battery box, which is usually half the effort to do in an electric car, we've already got the box done. Right,
the box is
and it's
built.
One big box.
One big box that just
Very
slides
simple.
into the bed. Yeah.
And but to get to it, we have to do some hole cutting and some conduit and.
You have to bring these cables down under the vehicle.
Because I don't want anything chafing there.
No. No, and I think this should work real well.
Yeah, that ought to.
Yeah, I think
That
this
ought to
should
do
do
it.
it. Yeah.
So our Escalade's going to have enormous gland nuts. Is
Yeah,
that
it's-
right?
Yeah, big gland nuts.
Big gland nuts. Okay,
yeah,
cool.
Yeah. Yeah, you don't want to be carrying these around. They get in the way. But that's what the plan is, and we have begun the Escalade project. This is not street legal right now. I'm sure it'd be very loud.
Uh-huh. Well, I think if you could get that battery box in and those conduits, we'd be half done with it.
Yeah, we can start laying the batteries in, strap them and things, and what do we get? Our charger, DC to DC converter, and then we can start up on the front of the vehicle.
Yep.
Yeah.
All righty. Well, let's continue on. I guess we're you know, a lot of times they in television they used to say we were on the air. In this case, we're kind of up in the air.
We're in the air.
We're on the lift with the Escalade, and I have to tell you, it's I've been hesitant because once we disconnect that engine, it's tough to move this thing around.
It's a rack queen for a while. There's
Yeah,
not much we can
we're
do.
in the air and on the rack, but I guess we can go ahead and pull the gas tank and get those holes in.
Yep.
And hopefully get our box in and get that wired up.
Yeah, get some batteries in. I think we're on our way.
Cool.
Good news.
NetGain Motors, home of the Warp, Transwarp, and Impulse motors, introduced the improved Warp 9 motor. The Warp 9 is a 9 1/4 diameter series wound DC motor with a double-ended shaft featuring 26 improvements for 2010. Externally, the terminal studs have been enlarged from 3/8 to 1/2 inch diameter. Bigger is better. On the inside, a larger commutator, new brush composition, and split brush design with heavier springs handle even higher voltages and currents than before. Our new fan increases airflow by almost 50% over typical paddle-style fans. And all this translates into improved performance. For even more performance or larger applications, take a look at NetGain's Warp 11 motor, an 11 3/4 diameter series wound DC motor for even greater torque and power. Since 2002, NetGain Motors has been leading the EV industry with precision, performance, and price. Visit us at go-ev.com. NetGain Motors, warp power to go.
Well, that's good. That's a good way to start with that Escalade.
We're off and
I
running.
like that. And yeah, and it's been sitting around, and I think we're going to be able to get moving now.
Those holes down through the bed
Yeah.
are going to be kind of a pain.
They
but
are.
Once we get that done and get that box in, this project starts to collapse on us.
It's all here.
We had started it before and got most of the right parts
Yep.
going
Yep.
and had them pretty far along when that Cobra sort of interrupted.
Yes,
And
yeah,
so, I mean, the battery box is sitting over there.
Battery box is right behind us. Yeah, yeah.
The motors are sitting over there. The controllers are over there.
Batteries are here. Chargers
We
here.
have the batteries. We had to wait on those.
Yep.
And you know, I'm
DC,
thinking.
DC converter, charger. Yeah, we got a lot of stuff here.
Yeah, a lot of it's come in.
And having brakes is a big deal.
Having brakes is a big deal.
Yeah.
But having that battery box in, as we've seen again with the Cobra, half the task was batteries.
Yeah.
Brian sent me an email.
Oh, he did?
Wanting to know if he could take out some of them in the next version, if he could have less batteries. I'm like,
Well, I suppose.
I sure struggle. These guys came to me, wanted to have this car where you work it all out, the voltage and the current capability and the motor and the controller all kind of work together.
Yeah, it all works together. Yeah.
We can't put a 190 volt pack in this car with a controller that flips out at 130 volts.
130 volts. Yeah.
It just does not operate.
Right.
It quits.
Yeah. And you can have the same thing on the other side too.
And
Too
same
low
on the other
voltage.
side if
Yeah.
you have a.
Yeah.
And so, and that's all, as I try to explain to him, kind of a function of the car.
Right.
And what you want the car
What you want
to do.
Yeah.
Now, I think they can make some improvements to the Cobra, but you can't just randomly start changing
Start taking
things.
stuff off.
It's sort of a design.
Well, can't we just put a smaller fuel tank?
Well,
like batteries?
he wanted
Sure.
to know if he could have less boxes. That's fine. If you can make the boxes consolidated.
Right.
I don't care how they're laid out. I never really did like boxes underneath, that's always
Yeah,
the tip
it's
to
the
get
last
more
place to
batteries
put 'em,
in
yeah,
there.
yeah.
But it cuts down your clearance, and
Yep.
and so there you have it. But yeah, the answer there, Brian, is you can have fewer boxes. You can't have fewer batteries.
In fact, we could have put more batteries in that car.
Yeah, we actually that car was destined for 250 volts, 260, and we wound up at 230.
230, yeah.
Because I just couldn't do it.
Physically, we just couldn't get it in there, yeah. We
No,
kind of
no,
mishmashed
No,
them, yeah.
I could have. We
Yeah.
could have covered that motor and controller with it.
Yeah.
You would never. It'd be like a lot of these builds where you can't even get to most of the components.
Right. Once you
Would
seal it
not-
off with
Not
batteries.
be anything you could maintain or make changes. It would just be a nightmare.
Yep.
So anyway, we wound up with 230 volts at that voltage. You know, I'd put a warp 11 in there with those Hellwig brushes without batting an eye.
Yeah, I think
We
we
wouldn't
would
be
not be
arguing.
arguing. No, I think we'd be fine.
Moving that 3,000 pounds, we sagged down to, 180 volts. That's prime operating range for that.
For that anyway, yeah, where it really needs it, yeah.
You'd have a little bit more torque too. That's a 9-inch rotor in that 11 HV. It's so it'll do high voltage, and we never really did do the high voltage part. But we got good power out of it. It's a smoking car.
Yeah, it's a nice car.
Brian says he's had a lot of demo rides out there in Granby.
Yeah, I haven't talked to him in a couple of
they
days,
kinda
but
like it.
good. I'm glad because he was really enthusiastic and taking a lot of people for drives.
Batteries. You know, if you wanted to just make that a go-fast car and bail on the thing, these A123 cells, there's we're looking at these things. Every dog has his day, and it's kind of a function of price. You know, if I can give you a BMW 3 Series, at $50,000, maybe you're more of a Porsche guy.
Yeah.
Same car at 22 is a different
It
deal.
might swing you.
Maybe I'm a Beamer guy.
That's right. Maybe it's still German.
Right. And so, the world is a price-dependent place. I've got a little cabal in the peanut gallery that assume that I just do things randomly because we have the resources to do what we want to do. It
doesn't work that way, guys.
a child-mind view of things, but that's never been the case.
No, not at all.
It's all about the value proposition, and we've been measuring that stuff since the 80s, early 80s, in public. And it's a constant march because it changes over time, of course.
Right.
Today's $3,000 5-megabyte hard drive is not really impressive.
No, not impressive today.
Later, when you can get 20-megabyte drives for $1,000,
Right.
and now terabyte drives for
drive.
100. Things change over time,
Yeah.
And value changes and perceived value changes. At $65, A123 cell is of no interest to me.
No, it's just too damn expensive.
At $50, it's really not a player. Suddenly, I bought some for $30.
We could at least test them at that point, not feel so
it's a
bad.
20 amp hour cell for $30, buck and a half an amp hour. We can look at it. And they are lithium iron phosphate, which I like.
With nice chemistry, yeah.
And so let's take a look. It turns out most of them are not coming in at 20 amp hours.
Okay.
And not above at all.
Okay. All right.
This is more American style marketing. Selling 18 as a 20.
As a 20. Close enough.
There was one of them was 20 once.
Oh, okay.
So and I'd predicted this would happen. It's almost a polar from the Chinese.
Yeah,
marketing
right.
thing.
Yeah, exactly.
But
the opposite.
anyway, they're now talking $20 to $23, maybe even $21 for the same cells.
Yeah, so buck and an amp hour or a little more, yeah.
We kind of have to look at it at that thing.
Yeah.
And the reason is they use a nanophosphate powder
Oh, okay.
that lets them push a lot of current suddenly. So although they're 20 amp hour cells, each cell will do like 20C.
Okay.
Well, that's like,
Yeah, it's like 4,000 amps.
yeah, right.
That's a lot.
Not for very long.
No.
And I mean, you know, you still have the laws of physics and
Yeah.
the little tabs
Right.
to deal with.
Yeah.
But the cell itself, briefly, will put out a tremendous amount of current or power, basically 2,400 watts out of a,
You have a 20 amp hour
yeah.
cell. Wow.
And that's a lot of current.
That's a lot.
And but it opens the door to some different battery configurations where we can have smaller packs with shorter range, but every bit as much power. So if they wanted to declare the Cobra, for example, to instead of being a 120-mile car, a 40-mile car, with those cells, you could have it produce just as much current as the twin 90s that we have strapped up in there quite easily.
Yeah, it'd be a lot lighter and more powerful.
It would be a lot lighter.
Yeah.
There's
Faster
975 pounds of cells in that car.
Yeah.
If you got that down to 200 pounds, that's 700 pounds off of it. You're down at 2,300. If he can take 400 off, you're down at 1,800 in a Cobra with that Warp 11 in it. It's technically no longer a car.
Like that.
It's a low-flying aircraft.
It's getting good, guys.
So you can do things like that.
Yeah.
You know, now I don't want to do that. I wouldn't even want to ride in the car while you do that.
Even if we bolted down the seats?
No, even if we had bolt-in seats and seat belts. But, you know,
Come on.
Ron Adamowicz would go berserk for something
That's right.
like that. Yeah. And so that's the concept. So the problem is the cells are not in a usable form.
Right, they come in boxes laid down. Yeah.
At least you don't need 6,000 of them.
Yep.
But you have to have a module strategy. Let's show them some of our, now this is early stuff. We're just playing around right now, but it's kind of the direction that we want to go. And the criteria is weight, expense,
Right.
you know, how much work you want to put into this.
Right,
And, and then flexibility of the
To the configuration
To
of
the
the cells.
configuration of cells.
Yeah, absolutely.
Let's take a look.
Okay.
We're kind of having some developments in the battery business that I think may be seminal. I'm not sure I know what they mean. And they may not, I may be reading too much into it. However, it could be a pretty neat thing for the availability of batteries in general. The American companies have been trying to sell intellectual property, not batteries, and they've been trying to ally with OEMs. This has not worked out with them very well. And so their latest strategy about a year ago is to invest in OEMs or would-be OEMs who are going to manufacture cars and use a lot of electric batteries, and in this fashion be selected as the best battery and get in the battery business. It's not entirely a crazy strategy. If the car was successful and the batteries were successful, then this could lead to work with other manufacturers. Unfortunately, it hasn't turned out very well. The car business is very capital intensive, and there's many a slip betwixt the cup and the lip. One company sort of famous in the electric car business for having gone broke more than probably any other company in the history of automobiles is Think. This company's gone broke and been rescued so many times they don't know the difference. Apparently Interdell didn't either, because they invested $59 million in the new Think City version that they were going to use the Interdell Inter One lithium iron phosphate cell. think kind of went broke yet again, and is probably still going to survive. I understand they're moving to Russia now. But in the process, Dell has been delisted on the stock exchange. Similar company is A123, and they face kind of a similar fate. They invested $30 million in Fisker after not being selected for the Chevy Volt. Chevrolet had picked LG Chem, a pouch cell manufacturer of a lithium manganese oxide spinel cell that is used in the Chevy Volt today. I actually like the A123 cells better. A123 started with two guys at MIT, a $100,000 government grant, and have since then operated entirely on other people's money and government money. They've gone public. I should be incensed at this company because they have been actually abusively rude about not selling to what they see as the hobby community or the one-off, or they have various ways of alluding to it. They only sell to OEMs. In fairness, they had a very bad experience with an early conversion shop in Boulder with David D. Andrea of BMS fame, and a Toyota that had been converted to electric drive and a fire. And that, they think, caused them to lose the Volt contract, and so they want nothing to do with any individual people making conversions of automobiles. I kind of understand how they got there. I should still fault them for it, but they have invested $30 million in Fisker. And Fisker now has a $95,000 car that they're kind of, right now, furiously recasting as the Bentley of electric cars, to explain their micro sales of that car, which, as it turns out, is not terribly green. Gets about 20 miles per gallon after you turn on the gasoline engine, and at $95,000 is probably not going to find a market anywhere. And so A123 has their inventory piling up on them. They have recently announced an alliance with Chevrolet for the Spark. Now, the Spark is out there a year or two, and so there's no immediate relief, but that could make a difference in their long-term prospects. Meantime, they have this inventory of cells for Fisker that is building. The cell itself is more to my liking. It is a lithium iron phosphate cell. Lithium iron phosphate, as we've said several times, has a much higher temperature wherein it would release oxygen from the substance. Lithium cobalt oxide and lithium manganese oxide do so fairly readily, and that's why the swollen Macintosh batteries, the fires, the cell phone fires, and so forth. And I suspect that we'll see some problems with the Leaf and the Volt because of this metal oxide chemistry, not really from any fault of Chevrolet or Nissan. It's just a low incidence of it, but it's just an incidence of a chemistry that is not terribly stable, however well manufactured. A123 found a way, using a nano powder technique, to make the lithium iron phosphate, and there's no real magic sauce in it. Everybody adds a few rare earth metals in kind of a superstitious nod to the battery gods that they can somehow have a little bit better cell. But their trick was primarily a smaller particle. and that enabled it to put out a tremendous amount of power. We think of batteries in terms of energy and power. Energy is how much energy we have in a given weight or volume. In the case of A123, these have been variously listed, seem to be now at 495 grams, or right at a half a kilogram, about a pound, 1.1 pounds perhaps. And that holds ostensibly 20 amp hours at a nominal 3.3 volts. And so that gives us about a 66 watt per pound, or about 130 watts per kilogram density of storage capacity, energy. And that's my primary interest is in energy density and life cycles. Apparently these pouch cells are now testing out to some 3,000 cycles at 80% of their capacity remaining after 3,000 cycles, and life cycles are likewise important. I have not been too anxious about power, but power does have some application to cars. And power, when we say power ability, we're talking about the ability to instantaneously deliver current. And so our China Aviation Lithium Battery Company or Winston Battery Company cells are listed at about 10C. And that means that a 100 amp hour cell could put out about 10 times that briefly, or 1,000 amps. In practice, I don't think a 100 amp cell can put out 1,000 amps very long. And so we see perhaps 200 amp hour cells that could do 1,400 or 1,500 amps, let's say for 10 or 15 seconds. And so somewhere in the 700-800 amp, 7 or 8C is realistic with these cells. The A123 purports, I've seen all kinds of numbers, 20C, 60C, 100C, depending on for how long and under what conditions. We'll take a little closer look at that in a little bit, but they do put out a much stiffer amount of current for a given size than the cells we've been using. What does that mean? It opens the door to a kind of a thing that I don't think many of you are going to be too interested in. But for example, a drag racing application where you need a huge power and minimal weight, this is a much more attractive notion. And in fact, Ron Adamowicz is now marketing a high-end cell that's about a quarter of the size of this, say 6 amp hours, but again, we'll put out very high power. And so there is some applicability to that. What some others? You know, I've noticed we've been building these cars, noting about what I call a natural range of 80 miles for lithium iron phosphate cells. If you design the car properly, it's going to wind up being an 80-mile car. Now, it'll go 100 in a pinch, but we want those cells to get maximum life, 3,000 cycles or so, and so I call it an 80-mile car. Can we build a car that'll go 150 miles on lithium iron cells? Yes, we have to increase the a portion of the car's weight that is batteries, and it becomes kind of an awkward car as a car. What if we went the other way? No one thinks this way. But what if we decided we don't need 80 miles? Because I can tell you, for my purposes here in town, 35 or 40 miles would actually be adequate. That doesn't mean I would settle for lead acid, which either 35 or 40 miles starts deteriorating immediately, and this is with 1,200 pounds of cells. But what if I had a 50-mile car instead of an 80-mile car? if I went to a smaller cell to do that, I start to limit the amount of current that I can deliver at any one time. I don't want to give up acceleration. And so these types of cells open the door to a smaller, lighter pack with increased, if anything, performance. And if you needed to go further, you could double that pack size fairly easily. In other words, it increases the granularity of our cell ability. Now, the interesting aspect and why this is timely is that A123 still will not sell us the cells. They have established a distributor, Maven, who sells them to the motorcycle community. We got a quote from them of $65 a cell. Well, if we took 5 of those and made a 100 amp hour cell, that would be about $325 for a cell that we typically get for 110 bucks. And so 3 times the cost for the same basic storage capacity is not really anything we're looking for. And so if A123 would sell them to us, we assume that it would be something in that price range, and that's not terribly interesting. I ran into a company called OSN Power some months ago, 6 months ago perhaps, and they insisted that they could deliver A123 20 HD1 cells, which is this 20 amp hour. They're calling it a prismatic. It's not a polymer cell. This is a pouch cell, but it's a prismatic lithium iron phosphate cell. This is completely different from the CoCam cells, you understand, and I think much better chemistry. And they have them available at $50 each in sample sizes and $46 each in quantity. And I bought, I think, 16 of them and have been playing with them a little bit and puzzling what we might do with something like that, when another company contacted me and said they had A123 20 amp hour prismatics, and they would sell them for $30 and in a quantity of 600 or more at $23.80 each. Well, $23.80 for a 20 amp hour cell is rapidly approaching at least the China Aviation Lithium Battery Company level of cell costs. And so these start to become an option. We think that this pricing is going to deteriorate further. I got 36 of the $30 cells, and we've been looking at them. They, there is kind of a machine imprinted coating on here. It says B. Some of our other ones said A1 or A2. I don't know if this is some sort of a binning situation, a rating. I know that they have literally, someone has with a magic marker wiped out the Made in USA imprint that's on the cells that I'm sure A123 is very proud of, in spite of the fact that these cells are mostly made in Korea. The cylindrical cells mostly made in China. They're 26-650s. I believe these are primarily made in Korea. And either A123 has had their product sort of backdoored, which is unlikely, as these actually retain the printing of the A123, or these are from the factory that makes the A123 system cells, and they're allowing sales to Chinese trading companies and so forth. The price appears to be eroding somewhat. And so we face the very real possibility of being able to get these cells at the magic dollar an amp hour level. And that leads to what might we do with them? A half a kilogram, 20 amp hours. The granularity is quite good. You have these little tabs. Now, we've shown you the inside of a lithium iron phosphate cell, and it looks very little different if we put this in a plastic case and had kind of a claw to hold each of these with a bolt in the top. We could basically remake our existing cell. It wouldn't be too different in size and weight. This is 160 millimeters wide, 227 tall, counting the tabs. The tabs are 45 millimeters wide, and they're separated by about 35 millimeters in the center. Of course, they're conductive aluminum. One of them's aluminum, one looks to be nickel. And these would have to be assembled into some sort of module to be useful at all. We could not put them in a car like this. Let's take a look at how A123 handles that. So a lot of pieces, plastic pieces, little clamps, a laser, a welding. Those are little nickel sheets that they can use welders to weld the individual tabs to that cap piece and make a module. Of course, they have their vaunted battery management system and those circuit boards at the end. Each cell is in a little metal can so they can do something about heat sinking. And of course, it's all banded together. Now, I have to tell you that looks expensive, complicated, and a little bit fragile to me. But I have to also be the first to admit that I'm not a fast engineer. I'm not a slow engineer. I guess kind of a half-assed engineer in the electrical realm. And in packaging and a mechanical presentation, I was like not the cool kid in the second grade art class. It's difficult. But I'm going to make a stab at this because I find the notion attractive if we do another speedster, say with an aluminum frame in the spring, or a Factory 5 Racing Systems 818 World car, or something along those lines in a small car. There's some interesting developments in AC motors and controllers coming our way, and I'm pretty excited about 2012 for building relatively inexpensive and small, perky electric cars that I think could be a lot of fun. I think this can actually break into kind of a performance custom car zone that could be very popular with the younger car guys, and really be a new generation of hot rodding in electric cars using small frame vehicles. And so I kind of feel like this has got some promise, and we got to learn a little bit about it. How would I do a El Cheapo module with no BMS, no thermal? In my testing, these are no more thermally sensitive, as far as I can tell, than the existing prismatic cells we have. They do not get particularly hot, even while putting out quite a bit of current. A little bit up here Next to the terminals, there's a little heat that builds up, but it is quickly dissipated with the rest of it. And so I'm going to approach this until proven wrong as a ordinary lithium iron phosphate cell, and that we can build it without a battery management system and without any special cooling provisions. And then we'll, once we get that kind of working, we'll back up from there. Now, the first thing that comes to mind is how to put these tabs together. And we want to take up the minimum amount of space, and we want to have them securely with the maximum area connecting them, and we have to be able to connect to a larger world of big cables and clamps and so forth. Most of what I have seen done with this type of cell has involved plastics or Lexan or polycarbonate and CNC machines to make slots that the tabs stick up in and bend over, and then various plates and things on the top to clamp them into position. And I like all that, except for a couple of things. I've had some bad luck with even standard Molex type connectors because the plastic softens in the presence of heat. And then the terminals move around and things start to short, and I've just had some bad experiences with that. So I don't like plastics. There's actually a whole really neat area of 3D printing that would be ideal for this, at least in the prototype level. And I'd like to get into it. There's a open source version of this called the RipWrap that actually replicates, a self-replicating machine. It's a 3D plastics printer. But the problem is that these printers operate by melting plastic and depositing it, much as you would a ink in an inkjet printer, but in doing it in layers, you can produce a 3D device from CAD/CAM drawings. Cool, slow, but the plastic, of course, being that it can be melted to go through the machine, has got a fairly low melting temperature. Now, there are different materials there, and so this is a possibility, and I've looked at doing that. I'm kind of going a little lower tech in this case. We have a material I use around here quite a bit. Its trade name is Tyvar. It's an ultra-high molecular weight polyethylene. And ultra-high molecular weight polyethylene has a very low coefficient of friction. It's got a very strong dielectric, and it's fairly high temperature. But I have gotten it to burn, actually, if you get it to a certain temperature. And so we're not going to use that for our top, but having this very low coefficient of friction, one of the things that you'll find is that epoxy resin or polyester resin is used in fiberglass, won't stick to it at all. And that brings us to where I want to go with this, and that is, instead of machining plastic or material blanks into these kind of structures to allow us to assemble these into modules, I would like to cast it out of epoxy resin. Why is that? Epoxy has been around a long time. It's quite chemically inert, but its main sense here is that it's quite lightweight and it's very inexpensive. I can get a 1.5 gallon or gallon kit or 1.5 gallon kit on eBay of 2-to-1, which is the epoxy resin and hardener for $40 or $43, something like that. And that gives me enough that the little device we're going to cast from this is about 6 ounces of material, and so I could do a dozen of them for that. And so you wind up with $3 or $4 in the materials for this as far as the resin. It's very non-conductive, has good dielectric, and this stuff will go 450 degrees Fahrenheit, which is pretty good. It does not really soften even then, but it's relatively hard. It does take a day to cure, but it takes almost any shape. It has one weakness, and that is it just almost will not stick to Teflon or Tyvar, the ultra-high molecular weight polyethylene, or any polyethylene. It just can't be made to stick. And in fact, we've tried different strategies of gluing this Tyvar together, and we can't get anything to work. It just will not stick. So we're going to use this for our mold, since the epoxy won't rest in it. I have made a mold of a prototype out of the polyethylene. It's pretty ugly. I've got a series of plates here that go in the mold, and their main feature is by the cunning use of one nut in between them. They're each about 7.5, 8 millimeters apart. The A123 device is 7.5 millimeters thick nominally, and so that sets them about evenly spaced. So I've just taken some threaded rod, a bunch of nuts, and drilled holes in plates that have a little U cut out here, and each leg is a little over 45 millimeters across. It's about 30 millimeters between them. And I've set it in a square that's 160 millimeters on a side. Now the 160 millimeters is the width of the A123. In the mold, this is a threaded insert. You normally would drill a hole in wood, and with a Allen wrench or something, hex head wrench, you screw this into the wood, and then these big veins out here dig into the wood, and you have threads on the inside, in this case 1/4 by 20 threads to the inch, 1/4 inch in diameter. I drilled a number of holes in the mold and put in 1/4 screws, 3/4 of an inch long, or a 1/2 inch long, I can't remember. 20 threads to the inch. And I screwed these inserts down over the screw, and then put a little dab of wax in the top of them. And then I waxed the entire mold. This is a paste wax that you get from the fiberglass supply houses. This comes from fiberglasssite.com, which causes the resin, after it's cured, to release. This is a mold release agent, some purple stuff after the wax dries. You put that over it, and it causes a further release. And all of this to enable our mold to come apart and release our module head. The trick, of course, even though we waxed it, is getting our, looks like an old capacitor tuner from a 1934 Westinghouse radio, is to get our little plates out of the resin, and they're in there to create a slot for our tabs. And so I simply turn it back and forth and tap it with a hammer and slowly work it out. I want to retain the resin between each slot, but I want the slot so I can put the tab up through the resin. And so by alternately tapping this thing, eventually it will come free. Largely because I waxed it, polished it a little bit, and waxed it so that the epoxy would not stick to the aluminum very well. And that leaves in our mold, you can see the tabs for 2 sets of 5 of the devices. Let me see if I've got this little Black & Decker electric screwdriver that will probably run out before I get done. I'm going to go flip this over and take out my little 1/2 inch one inch, 1/4 inch 20 thread. It's 20 threads per inch screw that's very commonly available at the local hardware store. And I actually have 16 of these with these inserts in there, and that gets to be the most expensive part of it. I think I've got about $6 or $8 worth of inserts in there, but that would let me use these 1/4 inch screws to bolt down a metal plate to carry the current. And we're going to need to do some of that. One of the things I don't like about the A123s is it doesn't look like it's going to carry a whole lot of current. And I like just a little stronger interconnect than that if we're going to have some weight. And one of the downsides to this is every way I've approached this so far. Right now, a 12 volt 100 amp hour cell made this way doesn't quite do 100 amp hours, but worse than that, it weighs 25 pounds without a case. Well, 4 of our Calb 100 amp hour cells, which are over 100 amp hours, is 28 pounds. And so we're not going to achieve, really, by the time we modularize this, any advantage over the Chinese prismatics we already get in use. We're not going to get more energy per weight using these cells. It's just not true. We can get more power. I can turn around with a couple of these screws, thread them into these inserts from the other side, and pull up on that, and out comes my little device, which has been cast out of epoxy resin yesterday. Now, I had used my mold to spray some holes for something else through some of these holes with red paint yesterday, and so it's a little bit covered. But I will take that and clean it up, and we'll be right back. So that's our little cheapo ultra-high molecular weight mold, and it's ready to be used again. I can just put those screws right back in, another set of inserts, and wax it up, and it's ready to go. Again, I like working with the epoxy resin, 24 hours to cure, but very inexpensive, good dielectric, and cheap, and good temperature. I took our cast, and now you can see it. It has 16 of these inserts in it, and it has a bunch of slots. These, of course, just rest on the bottom of the mold. They're not perfectly even, and so they don't go all the way through. A little bit of fiberglass resin can get underneath them in some places, but I just hit it with a buffing wheel that has a wire brush on it, and that took off the red paint, and it can abrade this quite readily, and it took off most of that. So here's our little topper for a battery cell. And so what we have to do then is take some of our cells and assemble that. And let's see. I'm going to take a cell just like this, and it has a serial number on it. I have not found a lot of markings on here that made much sense. This has a serial number kind of denoting the negative terminal, but the negative terminal looks like it's nickel anyway, where the positive is aluminum, so I can tell those apart. It also has a negative and positive marked on it, and the serial number is right between them. And so let's see how this would go. Let me do the inside most one. And there we go. It slips right up in there. Let's take another cell. They come stacked in these plastic things. I like to pull this serial number off because I want maximum contact on that terminal. Let's pull that off. Oops. It came right out. And that pops through. And there we go. There's two of them. And here is our last one. We're going into the slot. And it went in. And we'll bend it over. And so we have two sets of 5 cells stuck through the device. Let's see, this is negative to positive. This is negative to positive. And so I probably need a tab over all of these. And let me see if this one that I've made earlier would actually do. You know, most of the holes line up. I'm going to cut out a little bit of tab here, fold it over. So we've clipped off a little bit of the inside tab so that it will not interfere with our holes. Let's see. Here's some 1/4 20" by 1/2 inch. And let's see if we can get that to go through one of our holes into an insert. Let's go to the other end. See if we can get one threaded there. The trick being, of course, to get your holes in your plate to line up with your holes where your inserts are. Now, if we take this a little further, we're obviously going to make some templates instead of hand drilling these. and simply cut out a bunch of this ahead of time with the holes already in them. And that would pretty much be our process. We've got a few screws in. On our cross plate. Let's turn these out for negative and positive. I think that one will work. I'll trim off these corners. Voila. Here we have our two 100 amp hour cells, and we go from negative to positive. Our positive is tied to the negative in the next one, and this one's negative to positive. And so we'll have about 6.6 volts between the two of them, and we have a little 6.6 volt 100 amp hour battery in theory. Now there's a couple of things wrong with that, and I'll show you what the biggest one is. We have managed to make a battery about twice as big as necessary because of our need for holes in these screws here. And we might be able to work around that because the tabs are fairly long and squeeze them together. Instead, we've done something else. Let's turn this way and get another one that we did earlier with copper plates. And we find that if we put this here and this here, we can actually kind of force these together, and they will eventually make a battery that is 12 volts, weighs about 25 pounds, and is 100 amp hours in theory. Now that only happens if these cells are 100 amp or 20 amp hour cells. As we're going to see, we're running into a little problem there. There's another little problem. As you can see, we're offset. We would need to tie this terminal and this terminal together, and that would give us a negative terminal here and a positive terminal here. And of course, we can shape those any number of different ways quite effectively. But we would wind up with a fairly compact 12 volt battery, 13.2 or 4 volts in actuality, and 100 amp hours if we had a case for this. As you can see, part of my problem in making it square is that I have a little excess top sticking out on this side and a little excess on this end here, and then this isn't enough. So we need to redo our mold where we have kind of an offset in where our 2 sets of 5 cells are. And perhaps we might make our mold a little bit larger. And it would sure be easier to make these little plates if our insert holes were in a regular dimension. And so we'll probably return for the second version of this by doing a second mold. We may go to a smaller insert and screw. We might be able to get by with a number 10, 32 threads per inch, or 1024, and an insert. And in fact, our inserts might be a little less money then. They're holding very well in the resin, and that lets us tighten down these screws quite nicely. And that's important in getting a little pressure on those tabs. Now there's another possibility. We may want to add a little metal bar between each tab, so when they fold over they're all raised to a uniform height, and that'll give us a little stronger clamping action against the plates. And of course the plates can be anything in any shape. I've kind of cut this out where there's a little gap between here. We would put a hole over here to attach a cable or whatever. This is simply a shorting strap between there. I'm probably going to go to aluminum instead of copper. We're mostly aluminum on the tabs. Some of them are nickel, and that'll prevent dissimilar metal corrosion. Although we're going to have steel screws, and we would put our Nordlock washers under the screw heads in actual practice, and have some sort of a regular bolt tab here. We could also arrange these, say 4 wide, and butted right up against each other, and then this could be, instead of a tab that connects to here, it could go straight across to the next set of cells, just like this shorting plate is short here. I could have 4 of these in a row, and that would give me 48 volts. If I did them too high, that would be 96. It would really be over 100 volts because you're a little higher than 12 volts on these. But it gives us a fairly compact package. These are 25 pounds the way they are. Now by the time we put them in a case, that's going to be up around the 28 pounds that for the Calb 100s is anyway. I don't think there's really any volumetric savings, but we can make the modules the length and shape that we want. In other words, within the constraint of this 160 millimeters, I could make this the length of the table. And just have one after another. In fact, I could do a resin mold that simply had these lined up, and with the inserts in it and the whole thing. And at that point, it's just a matter of screwing in inserts and waxing it down and casting it over and over for a low-cost, lightweight, dielectric, and with good temperature endurance resin end plate to hold these cells. So this is how I would go with a battery module made out of pouches. I have to tell you, almost any of our viewers would be better at packaging than I am. I'd like to come up with some sort of a contest to do this, actually, to where you we have some sort of competition to come up with a less expensive, lighter, denser package for these kind of pouch cells that would work with the smaller Haydens that Adam works with, and with the A123s. This episode of EVTV is brought to you by the Winston Battery Company Limited, makers of high-capacity lithium-yttrium rare earth cells, including the popular 160 amp-hour model featuring cycle lives in excess of 5,000 cycles when discharged to 70%, the longest useful working life of any available battery of any chemistry. A leading battery technology scientist, inventor, and entrepreneur since 1995, Mr. Winston Chung envisions a new world of clean electric power for the dawn of a new era of electric vehicles. For your next electric vehicle design project, contact Winston Battery Limited. Energy for a bright future.
I think it's an interesting concept.
Crude mold right now. I redid one today.
Yep, we have a new mold we're working on, yeah.
It's a little more normalized with the bolts kind of in regular places and a little offset, so these two ends will line up.
Oh, when we stack them together, try to make a battery, yeah.
And I've got my first cast in right now, so I'm not going to show. We'll run that next week.
Okay.
That's that's kind of what's going on there with the batteries.
Yeah, I like that. Yeah.
So
I like that.
Oh, we got our tires in. Let me show you a
Roll
Bridgestone.
I'll put it up here.
Let's do.
Okay.
Here's Lee's wheel with the Bridgestone Ecopia EP100 low rolling resistance tire, and we've got him in a 185/65 R15. That's what we've been using.
Yeah, which I think is the smallest one they make. Yeah.
And I think that will work very well in his car. There we go. Cool, huh?
Hey, what were you saying last week? These were the tires that were on the car.
Originally. That's what they say. That's what was stated in the May 1998 magazine article. So we're just going back to Bill Bishoprick's original design.
Design with the tires.
But I think this looks more normal to me than those Toyos. Those Toyos were kind of kids' tires.
They were a little too low profile for the car.
Yeah.
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 This will fill up the wheel well with a little bit of rubber.
And it'll roll a little better.
Yeah. Yeah, we like these tires. They roll nice.
So that's the Swallow. That's the Escalade. That's what we're doing with the A123s. Our Nordlock washers.
Okay.
Christopher Fisher is now in Sweden and went and visited them.
That's right. Oh, he did. He went to Nordlock. Okay.
He shot some video at Nordlock. Let's take a look.
Okay.
Östersund in a small town called Hallen, or Halabacken, where this factory is located. This is where they produce all the Nordlock washers. Ja, hej, det var Per Eklund. Vi är här och ska besöka Daniel Eriksson.
Ja, men då släpper jag in dig. Jag ska försöka ringa honom.
Bra, tackar. Ja, vad bra.
Fast de visste ju om att det är så mycket nu. Det är mycket nu, ja. Och så är det opererat och så han. Fast de här blommorna står inte på torsdag nu då. På torsdag? Ja. Har du stiftsmöte? Ja, just det, ja. Ja, det måste du ju göra.
Unglued washers with blue boxes over there. And we also have a standard package waiting for delivery. That's less 1 week of delivery in this area.
Okay. kind of forecast do you have in production? Production for like just in time?
More or less. What we you buy these ones in one each time.
Yeah.
This takes more or less 12 weeks to produce.
Okay.
So we need to have something in stock, otherwise it's difficult. And also in this application when you use this kind of washer. And this is the self-control. We're controlling in each production step. And I will show you later also when we have the quality department. They make also the same testing once again to ensure that we haven't made any wrong.
So the first thing we're going to show, it's normally 8.8 screw. And that's our stud that we're using? Okay.
Excuse me?
That's the stud we're going to screw the nut and washer onto, right?
Yeah.
Okay.
And then the first test I will show you what happened when you only use a nut without any locking.
Okay.
Then I take only normal nut and I will load it to a preload of 18 kilo, eller vad säger man? Kilonewton, yeah. Then I choose normal nut and start the vibration. And you can see the nut is turning loose. The curve is, and after 10 seconds, nut is loose. Then I will make a new test, secured by Nordlock. And preload is the same, 18 kilonewton. There, and then I start the vibration.
Did it even move?
A little. We have some. I have
The nut and the washers need to find their position.
And they find an equilibrium and then they just don't move after that. Wow.
And so that would require first reinforcing of the nut. Let's say after a couple of hours of use, or no, you don't have to. Okay. But if we can run the test once, yeah, you'll see it will be more and more stable.
and okay.
Wow.
Then I will show you what happened when we loosen this now. And then I will start it now. Then you can see on the car we have a higher force in the screw. And,
So it's a higher force to loosen it than it is to hold it.
You have a higher force in the screw, and that's the force to this self-locking. That's to overcome the cams, just to get the cams to pass each other the first time. Yeah. And the height of the cam is bigger than the pitch of
the threads on the bolt.
Yeah. Okay. But then we can I can show you what happened with nylon lock nut.
With no washer or no
no Norblock, no security washer, just this kind of nut.
Mm-hmm. Right.
Do you think it will
nylock?
Do you think it will loosen or not?
Yes, it's going to loosen. That's what I'm going to go with.
The same preload. Then I start the vibration. And then you can see on this car we lose almost all preload in the screw. We just have 1 kilonewton left. But if we're looking on this, yes, we think that it's
still tight.
It's still tight
because the nut won't actually spin, but it hasn't. It's still not tight.
So this equipment is very good to have on the next exhibition.
Mm-hmm. For salespeople to take around.
Yeah.
Do you sell these also?
No, we have our sales guy. They use it. So we don't sell them. We have rented them out for the sales people. It's very easy to describe how it works.
Right. Great.
But this is the worst case,
Mm-hmm.
of course.
NetGain Controls introduces the new Warp Drive Industrial Controller. The Industrial is designed to handle a maximum of 1400 amps and up to a 360 volt nominal battery pack. The unit's rugged design looks and works great in the automotive environment while protecting it from the elements. In addition to higher continuous currents than the classic Warp Drive controller, the Industrial comes with several major enhancements. Liquid cooling is available and uses leak-free and rugged AN fittings. The Industrial controller has complete isolation on both throttle channels, giving the highest possible immunity from situations that might affect the electrical throttle input. High voltage connections are fully protected underneath the sealed cover. Voltage leaks between vehicle chassis and a battery pack are detected, alerting the user to potential safety problems. Controller settings can be completely customized using the NetGain Controls interface module, which can also log data to an onboard SD card. The controller weighs in at 25 pounds. Visit www.ngcontrols.com to order your Warp Drive Industrial Controller now. Well, we like Nordlocks.
Well,
and they got to make them somewhere. That's pretty cool.
I've gotten where I've been getting well, they're like grade 8 stainless. The bolts we use with most of those prismatics are 16 millimeter cap screws, M8, 1.25 thread per inch, 16 millimeters long. I've been getting some little better of those from McMaster Car.
Yeah, the stainless bolts,
and those Nordlocks. And of course we use the braided straps from EV Works in Australia. And that's what we're going to apply here on the Swallow. But that's where Nordlocks come from.
That's pretty cool.
Why we use them.
Yeah, that is pretty cool, the Nordlock.
Christopher also visited one of our recent, one of our viewers, Per Eklund, is a fairly regular contributor on the blog and so forth. And Chris went to see him, and here's what he found out.
All right.
All right, so Per, we're going to take a test drive in your car, right?
Yeah.
And we're going to go to a location where we can get better shooting in sun.
Yeah.
And see how it goes. Yeah, some more space. Okay.
Yeah, let's go.
When you're ready. So when did you buy this car?
I bought it about 3 years ago. Yeah, a little over 3 years ago. I saw an ad on the electric car forum here in Sweden. A guy was selling his project car. It was a car that was missing the controller, the ECU. It was missing more or less every part except the motor and the transmission. So I thought maybe this could be an interesting project to start with, because I was thinking about doing a real conversion at first, but I thought I'll start off a bit with something a bit more easy to use with, to start with a car that's already electric drive but just has to get some new batteries or but I didn't know what I was buying before I bought it. So, some of the main the main cables in the car had been cut, so I had to get one of those cable harnesses for that connects the ECU to the rest of the car, and that was. Luckily I found one, but...
now this wasn't new, of course. You had to buy it off of someone else. Had a bunch of parts for these cars, or? Yeah,
some of the salvation yards has some parts, but mainly it's just people that has been lucky enough to get parts from cars that has been wrecked or that is missing batteries, or it's just like standing somewhere, people owning cars but just
not doing anything with them. So how long did it take for you to I guess get it into a running condition?
It took almost a year to do that. But I would say that of course getting all the parts together was one thing that took time. I had to find the throttle sensor and everything like that, because it was missing from this car. It had been the previous owner had tried to use a Curtis controller in it, but he didn't get it to work properly. So
because it's a CPEX motor in here.
Yeah, it's a CPEX motor from ABB. That was taken to this car from the original design. So they actually, ABB contracted a Norwegian company to do the controller, and then I guess Renault just bought the controller and motor package from ABB. and they made it that to a rebuilt gearbox from their standard gearbox selection from their like normal Clios, which was a manual transmission. So they just kept one of the gear sets instead of having 5 sets of gears. So it's a fixed ratio of 1:8.
Huh. And it works pretty good for you. You don't have to you don't have to shift gears at all, and
No.
go. It rides really nice.
Yeah, it's nice, but it's a bit limited in speed. So that's the only thing that I miss. I could take a little bit more speed. It's doing about 95 kilometers per hour top speed, but I wish I could do 120 at least.
Well, you made some sort of attempt to bypass all the normal engineering in the car, right? Get more power out of it?
Yeah, but that wouldn't have helped to get more speed, because the speed is limited by the controller. It has a pickup on the motor, so it senses the RPM all the time, and it actually uses the region of the Zepex to limit the RPM of the motor. So it will never spin more than just below 8,000 RPM.
Okay. The original charge port for the car was what type?
Well, I'm not sure if it has like a standard name for it, but we always call it a Marshall port, because that was the name of the company doing the plugs, and it's like a glove that just slip into the tracks here and just push it down.
Mm-hmm.
So this is the charge port. It's got a couple of connectors. This cable is not fully equipped with all the cables, but the system, the charge port, is actually capable of doing high current DC charging also. And there's receptacles for that in the car also. The connector is only good for one phase 240.
Okay.
But it's possible to equip it with three-phase 400, or to use also high current DC.
Okay. And are you able to plug it in real quick and show people how that works?
It's really hard.
Yeah, that is incredibly difficult.
And then you can also close the lid, and when you lock the car, it locks the lid also.
Huh. Fantastic. Okay. And then it comes out just as easy.
Yeah. You have to push the button though.
Okay. Very neat.
That's it. This is the charger. And it's connected straight to here for fuse block here that goes to the main pack cables. The box here is the motor controller, and below that is the actual motor with the blower in front there.
So this is the forced air cooling?
Yeah, that's the forced air cooling. There's no fan inside the motor, so it's forced air. Yeah, and you can see that the controller was produced in 1997 in week 50. So that's That's a late model controller. That controller is actually from the other car that I'm trying to get wrong.
So where do you put all the batteries in this car?
Well, the batteries are placed in 2 boxes, and that's also from the original scheme of placing the batteries. They were placed underneath the back seat, but they were placed from underneath the car, so the car was actually closed up here, and there was no way to get to the batteries from inside the car. So the previous owner cut the floor open here to be able to monitor the batteries better, and also to be able to move them in and out of the battery pack. But the original battery box was just a frame, so it wasn't closed. I have had a box manufactured, and I have put the batteries in closed boxes now.
And you have a little insulation there?
Yeah, there's a 1 centimeter of insulation both underneath on all the sides and one on the top also.
So these battery boxes are manufactured by a gentleman in Stockholm?
Yeah, he did a drawing for it and measurements for the car, so it's actually made especially for the Clio car.
Nice.
And he has done like 15 of these boxes, I think. So you can you can buy the kit for this box, and you just have to pop rivet it together and glue it together, or if you have a weld that could do a spot weld, you just spot weld it together, and it's a perfect fit for everything in this box, and it fits the car like magic.
And so you strapped your batteries together here with the Thunder Sky straps?
Yeah, it's just that I didn't know what kind of configuration I would use in the car, so I didn't order them pre-strapped in the way that they are now. So I had to do my own straps, but keep the sides. So because they were all delivered in 4 packs, so, and these are packs of 3, and in the back box I have packs of 7.
Do you have Nordlock washers on here?
Yeah, on all the terminals I have Nordlock washers, and also on the contactors that are between the batteries here.
See, so there's supports in there for the battery wall, the box wall. Oh, those are cables going through.
Those are actually the brake cables for the parking brake that's stupidly drawn straight through the battery box, and that's the original design, so we had to take that into account when doing the boxes. It's a really stupid way to do it, because yeah, you could have used that space for more cells instead.
Yeah. So you have.
Yeah, I only have one of these braided straps because there's a different measurement between the
terminals with 2 batteries.
Yeah,
and
when you have them like that. But so you can't use the same straps from going that way to going sideways. So, and I only have one of these, so I'm gonna get some more and put on the other ones that are the same. So right now I don't have a fuse because I blew that in my attempt to get some more power out of the controller. But yeah.
So with the temperature and the performance of the batteries, you said when you had them they were open box, you noticed it.
Yeah,
you really would see the difference.
They would sag more, and they would never heat up the way they do with the closed boxes. I used the car in minus 25 degrees Celsius during the winter with the open boxes, the first winter, and now this last winter with the closed boxes, the difference was quite
significant.
Noticeable.
Yeah. Now this is a box that's also manufactured by the same guy?
Yeah, it's the kit with the 2 boxes. So.
Okay.
So it's just an aluminum lid, and then the rest is like galvanized steel, different thickness. And this is the rest of the Thunder Skies.
So that's a pretty good weight balance on the car you have, because you only have the electronics and the motor up front, and then the batteries in the middle, and them.
I don't know the actual balance of the car, but or the weight distribution, but it's quite okay. It handles quite okay.
You're gonna get the braided straps for all these batteries, or?
Well, I don't think so. I haven't had any problems with the solid straps, so
Especially with the Nordlocks, right?
yeah, I'm just gonna switch these ones that are not real straps right now. That are more like cables. So that's my main goal, I think.
Oh, so these cells are numbered, I see, in some form.
Yeah, that's the standard number that came on the. That's the production number. I haven't done anything else. Those small letters there, they're. I think that's from the factory also. I haven't done any. I didn't do any measurements or anything on these before I put them in the car, and that's one of the things that I kind of regret. I would have wanted to do some charge and discharge tests before I put them in the car, but I didn't have the charger or discharger to do that at the time. So.
But now you actually have a battery lab, and you do some of the tests on your other batteries.
Yeah, I do some tests now, but I mean that I didn't have that 2 years ago when I put the car together.
Right.
It's just an interest that grew. So this is the my small battery lab or small workshop, electric workshop. I'm right in the middle of matching my new battery pack for the car that I'm restoring right now. I'm restoring another Clio, Renault Clio, and I have a selection of 120 Thunder Sky 40 amp hours that I'm going to arrange in the combination of 3 parallel and then 40 in series, so I would get roughly 120 amp hours and 128 volts. And right now I'm actually doing a capacity test of one of the cells. I have tested the capacity of all the cells like 6 or 7 months ago, and now I'm doing a cell again to see if I have lost any capacity just by storing them. I'm doing quite low current. I'm doing just 1/8C because the charger that I'm using, or the discharger in this case, is only capable of 5 amps. So that's what I started with, and that way I had to keep doing 5 amps for the whole set. So I have already tested all the cells on the floor here, and to be able to match them properly. I got the iCharger 3010B there on the floor that I also used to do the charge and discharge tests, but since I started with the small charger, I had to do 5 amp discharge with that one also. It's just that I had 2 chargers to use. But right now I can do 30 amps charge and 30 amps discharge in up to 10 cells. So
it says NiCad there on the charger settings.
yeah, I'm discharging the Thunder Skies right now, and this GG Power charger, and this charger only has certain settings for the lithium iron phosphate cells. It discharges to 2 volts, and I don't want to discharge the cells to 2 volts. I want to do them to 2.5 volts. So that way I go to the NiCad settings. I can set the end voltage in steps of 1/10 of a volt. So I can set the end voltage to 2.5.
That's pretty accurate.
It's the same program anyway. I'm doing 5 amps constant current until 2.5 volts instead of 2 volts, as the charger is pre-programmed to do in lithium iron phosphate mode.
So where are you right now? On you've already charged this earlier today, and
yeah, where we
you're
have
in the discharge phase.
Yeah, we have discharged 23 amp hours roughly, and we're down to 3.00 volts, and so we're heading for 2.5, which is practically totally dead with this light load. But that's the way I tested them the last time that I did them, so that's the way I want to test them now, to have the same setup. Maybe it's a bit warmer in here right now than I had the last time, but it shouldn't be that much difference, especially not at this low load.
Now, would this be a good way to, say, sort of automatically balance your cells, like bottom balance your cells?
Yeah, of course. I mean, there's these, at least this iCharger has a program for storage mode and for discharge mode of lithium cells. So you could actually, there's one program that does constant current down to a fixed voltage, and then constant voltage until a certain current. So just the way you would do a charge, constant current, constant voltage, you would do a discharge the opposite way, and then you would have a balanced or a fixed voltage. You would have a cell that is actually stays at that voltage. So I would say that having one of these RC chargers is pretty neat when you're trying to do this kind of matching, and even if you just want to balance your pack, if you have single cells in your series string, they do a good work, and most of them are totally accurate also. I mean, they measure 5 amp hour cells or 1 amp hour cells for RC, so they count milliamp hours. That's the accuracy of it.
Oh yeah, that's right.
So
I remember that now.
You could do, and you could also set them to discharge a certain amount of current, or amp hours. So you could set them up to discharge 50 amp hours, and then they cut. So I think they're great, and I mean that's about the most powerful RC charger that you can get now. It's capable of 30 amps in, 30 amps out, and the neat thing about this one is that it's actually kind of a two-way DC-DC. So you could actually have like a lead acid pack that feeds this one, and when you do a discharge, it puts the energy back into the lead acid pack that you're feeding your charger from.
So you can sort of shuttle energy back and forth between your...
And it's about, I think I've read it's about 85 to 90% efficiency. So
well, let's see.
You
Go
lose
ahead and take it out of there.
You lose some, but still it's better than losing everything and just generating heat.
So you got banana plugs on the end there.
Yeah, that's the input. So it would take 4.5 volts to 38 volts inputs. So you could do with the 3 lead acids, 12 volt blocks, but some people has had a bit of problem because, I mean, lead acid isn't 12 volts. It's more like 13.8 or fully charged. So I have just used it with a 12 volt power supply or with a couple of lithium cells, actually, making something. I think I used 5 cells or 6 cells powering it and restoring power from it.
Well, it's nice getting the reports from Europe.
It is.
What everybody's doing, yeah.
We need to have bureaus around the world.
Around the world, global.
24-hour news coverage.
Something like that.
So anyway, we're going to keep after the Escalade and the Swallow. That's our main
That's what
project
we're doing right now, yeah.
We're going to pursue the A123 cells a little bit, and I'm not going to get into a panic about that, but if the price keeps coming down,
it's an option for certain applications. Yeah.
well, they're not 20 amp hour cells, guys. We're not seeing that.
No, not in a lab. Certainly
from
aren't.
16 and a half up to 19 and a half, maybe.
Yeah.
I don't know if we're getting seconds or different binnings or,
we don't know.
or what out of Asia. It's kind of hard to tell,
Yeah.
but but at some price, it all works.
That's right. Yeah. Yep.
If I
At
need
some
6
price.
to make a 100 amp hour cell, I need 6. you
Yeah,
know.
whatever they work out to be.
The attraction here, and it's maybe not, we're not going to save any weight. We're not going to get more battery for less weight this way. We're not going to get more range.
No, we're not going to save on price.
We're not going to save on volume.
No.
What we might gain is a little bit of flexibility in fitting batteries into odd little cars because of the granularity of this.
Yeah.
If we're careful with the way we deal with
The
modules.
way we do the modules, yeah.
And we get power. We can trade range for power now.
Yeah.
In a sense.
You
could build a car with lighter weight and less batteries and still be able to fully punch the ticket on your controller and motor.
Yeah, get the full performance out of it, yeah.
And that's so you don't accelerate from 0 to 60 in 5 seconds often, but it's your car. If you want to do that, you should be able to.
That's right.
And that you're idling along at 22 miles an hour most of the time is your business.
Right.
But it's available then.
Yeah, no, that's cool.
And
I like it.
I think that'd be an interesting option. The other thing it allows you to do that we really haven't been able to do. So you can't really halfway do a battery pack because you wind up with half the power.
Half the power, yeah.
And so in this case, we could half our range while retaining the power, but that also kind of halves our investment in battery.
Yeah, true enough.
And so we can do a car perfectly serviceably and drive it with a $4,000 battery pack in it now instead of a $2,500 lead acid pack.
Right. Now it's starting to get close, yeah.
And just as much range.
Yeah.
But we still have room left over to add another one of those later if we want to.
If you want to, exactly.
And so that's the allure of the A123s. And it winds up being, so far, a big pain in the schwanz.
Yeah, we're on our second iteration of the module layout, yeah.
It is, but that's I knew that going in, right?
Yeah, we didn't know how they were going to look like.
We need 7 iterations of the module.
Yeah, because we don't know.
And we need module and half module molds.
Right.
And
yeah,
it's
a lot.
It just keeps going.
Keep going.
And you can see pretty much the same process at A123. Now they do a very deluxe thing. I'm doing a little bit more Jack Rickard style, quick and dirty. I think so far mine have been running very cool. I don't have any little laser welds and stuff carrying a bunch of current. I've got plates, and they're running at 70 degrees Fahrenheit and 300-400 amps. I'm not heating anything up.
No,
it's amazing.
Yeah, yep.
In fact, I'm kind of using the connection as the heat sink, if you notice.
Yeah,
that's
coming all the way across
sort of an unusual approach, but it's turning out that way. With enough terminal plate, I don't need their thermal management.
Well, you got heat sink right at the tabs, where all the heat is.
Where the heat is.
Yeah, yeah.
And so that's part of the strategy. The other is to get it to be cheap and reproducible.
Right.
And I like our molding epoxy resin.
Yeah, it's working. It's coming out of the molds.
Yeah, we'll get 100 scientific comments from people posturing as epoxy experts. But,
they're everywhere, I tell you.
If I need one, we can always call Dwayne Ball.
We can call Dwayne, yeah. If he doesn't know, he'll find somebody.
Dwayne 904, he's actually been in that business for many years.
Yeah.
And knows a lot about that. I haven't really beat him up on this. We're just using like bar top epoxy resin and stuff that's laying around.
Yeah, we're not using anything high tech.
But if we have any problems, I know where to go to get the right formulation.
Yes.
And for this, and but just getting the geometry right so far is kind of a pain.
Yeah. Yep.
That's our Thanksgiving, Turkey Day, Black Friday show.
That's it.
We'll see you all next week. Stay with us.
Bye.
I've had an unusual request. Bruce Sherry has been very good at working with us, although we've been paying, with how to use their state of charge head. Bruce Sherry is with Bruce Sherry Designs and has a neat little device with a shunt. It reports over USB the amp hours, has some relays you can control, voltage, current, and some other things. It works with a BMS he designed for Manzanita Micro that we don't have a whole lot of interest in. Manzanita Micro has almost been abusive in their dislike for us. So I was kind of surprised. Bruce asked me to mention that they're not an advertiser of ours of any kind, but asked me to mention that they are having a Cyber Monday sale after Thanksgiving, and so I thought that it was such a preposterous request, I would actually honor it. They're going to take 10% off of the price of any Zilla 2K or any of their chargers for just like 4 or 5 hours Monday morning, November 28th at www.manzanitamicro.com, I think, on their line of Manzanita chargers, and the Zilla is apparently back in production, and they had asked Bruce to ask me to mention it on the show, and it's such a preposterous request under the circumstances that I think I should. In any event, our viewers, it's an opportunity for them to save 10% if you were considering the purchase of a Manzanita micro charger or a Zilla 2K controller. They're 10% off between, I believe, 7 a.m. and noon Pacific Standard Time. They're in Manzanita, Oregon, I believe. So you can save 10% on a charger or a controller there. They have some other elements to the sale, like you get a free fully optioned hairball with Zilla, or free state of charge head with a BMS purchase. There's some more complicated things, but basically it's a 10% off sale on their two main products, the Zilla controller and the Manzanita micro charger.